Not that I know of. I actually just did the notes.
Oh, okay. Well, then that honestly, that'll help as I'm referencing back and forth, to be honest. I know had you had them done, you probably would have heard me say the same stuff on Wednesday as I did on Monday a little bit. Did you notice that I had updated stuff in the grade book?
I did not. I haven't checked the grade book.
That's okay. I just know that I had one or two people who were either emailing me and then the next assignment they would upload it to Google Classroom, and now at least I know before I start emailing back and forth, hey, you didn't do it, or thanks, I should look in both places. So just know that you can upload that similarity test to Google Classroom, take pictures. There's something, and I don't understand what people are doing. I wish I was, the fact that I can do this is still shocking to me, this whole technology, digital stuff. But they're uploading them in one way where I can't even click on them to make them get bigger. If I try to download them, it won't work. So whatever, if you take a picture of it and email me those couple pictures, that'll work perfect. If not, I know that you can drop them, like turn them in Google Classroom. And if you're still working on your test, that's fine. Just email that to me as soon as you get finished with it. And remember, let's say, I don't know, next week or the week after, you got distracted with something or too much work in history or something like that. The even questions, remember, are all extra credit. And because most of the odds are the same as the evens, I found that I've had a couple students just do the whole test and they've gotten like 27 extra credit points, which actually is more than I think the test itself is worth. So if you're interested in doing that extra credit, just know that you still have some time and you can email that to me at any point. Other than the test, and then these two no reassignments that are in the 9-1 and 9-2, everything else is last quarter. And even though it's continuous grading, I can't really go back into third quarter and fix anything. However, I can incorporate stuff into fourth quarter. So let's say that you did the 8-3 or 8-4 stuff and you want to still get that to me, take a picture of it, send it to me, and I can try to figure out how to work that into fourth quarter so it helps your overall semester grade. So it kind of offsets what might not have been put in for third quarter. Does that make sense?
Yeah.
Okay. So just know you can still hand all that stuff in. I'm going to get started, and this will help. I mentioned it on Monday. I mentioned it again on Wednesday. So you're going to see in the no reassignment, the 9-1 only has, I think, 10 questions. It's 10 or 11 questions. The first like 4 or 5 are just, can you fill them in?
Okay.
And in my opinion, it's a lot easier than even some of the stuff that you might have been looking at in chapter 8. So I'll try to go through this as quick and painless as possible for you. And then hopefully, if you have any questions, you can ask as we go. First thing here is I'm hoping that you can see that we have one triangle here. We have another triangle here. And this whole thing is one big triangle. So what happens is, because this big triangle SPN also duplicates S in SCP, that angle right here is a reflexive angle. It's the same angle in the same position. It corresponds, and it's the same measure. So that's reflexive because it corresponds. And later we're going to look at something that has the same measure, has the same segment, but they don't correspond, and it's not reflexive. It's called a geometric mean. So we have our reflexive angles here. On the other side, up here, we have another triangle that does the exact same thing with N. And that is another reflexive angle. So this angle and this angle up here are the exact same angle, and they correspond. So that's why we can say it's reflexive, because those are corresponding angles, meaning they're in the same position, in the same spot, and they do, in fact, because they're reflexive, have the same measure. So what ends up happening is every time we have these right triangles, I'm going to draw this guy just so that we can see that it's the original one we started with. In each of these, we have two angles that are the same. So between these two, you have two angles that are the same. Well, that makes them similar by angle, angle. In these two, you have two angles that are the same. Makes these two similar by angle, angle. If a triangle adds up to 180 degrees and all of them already have 90, that means these two that are left are what we recall being complementary. They have to add up to 90 degrees. Again, complements add up to 90 degrees. So regardless of what this measure is, if I subtract from 90, I'm always going to get this guy back. If it's the same measure here and I subtract from 90, shouldn't I always get that same number back? So what ends up happening, and again, if I subtract that from 90, I should get that same number back. So every time we pull these triangles apart, whatever you choose to put as your tick marks, if you mark your reflexive, the other one's got to show up. If you mark your reflexive, the other one has to show up. There's no way around it. The addition with 180 and our triangle sum being 180 will always have those become the same angles. So I have the orange here, a blue one goes there. I have a blue one here, the same measure has to go here. So whatever that was, the orange one's there. And if you want to look at it a little bit more, especially because you just said you took the notes to kind of make it make a little bit more sense, give me an angle measure for S. I won't even make one up myself. Give me something here.
45.
Pick another one. That's a bad one. Sorry, I should have said not 45.
30.
Okay, so if we picked 45 and I would have subtracted, that guy would have to be 45. So then what you'd look at for this example is everything would be 90s and 45s, and it wouldn't make as much sense. So you said 30. If I subtract from 90, that guy's got to be 60. Well, if this is 30, the reflexive has to be 30. Is this guy going to be anything other than 60? Like when we subtract from 90, wouldn't it always have to be 60?
Yeah.
All right. So that's going to show up no matter what. Well, if I go back to the original big triangle and we talk about this guy being reflexive, well, we already said it was 60. If I subtract 60 from 90, what's this guy going to have to be over here?
30.
So what ends up happening is no matter what, that's how those, you could have picked 17 and 2/3 degrees. Whatever I subtract from 90, it's going to be the same if I put the 17 and 2/3 here and subtract from 90, it's going to show up again. And whatever that guy was, which would be 62 and 1/3, I'd have it over here, 62 and 1/3. The 17 and 2/3 would have to show up over here because we're doing this addition and subtraction all the same. So that's why all of these guys are similar, which is why those guys show up. So when you do these questions in Knowre, what you're looking at is maybe sketch something like this on a scrap piece of paper, put your tick marks in, now understanding why it's going to happen. And what you'll be able to do is find that pattern. So when I look at the fact that they named this NPS, I'm going to look here and it tells me that it was orange, a right angle, and blue. So my pattern, at least for what I'm trying to make sure I get this correct, is orange, right, and then the blue one. So every time I go to name, I want to start in the same pattern. Orange, right, blue. That was the big one. NPS. And I will tell you, because I've done the assignment, doesn't matter which triangle you put in which blank, it will still count it as correct as long as your letters are in the correct order. So this one was orange, right, blue. I'm going to do orange, right, blue in the same pattern. So orange, right, blue. That way I have the same pattern. And when I go to the other triangle, this little guy down here, I want to follow the same pattern. Orange, I know that's got to be a right angle, and blue. So that's why this one would now be PCS, orange, right, blue. And like I said, there's at least, off the top of my head, I think I did 3 or it could be even 3 to 5 questions that it was just this repeat every time, knowing how to write those triangles. So did that make sense?
Yeah.
Okay. I have Blake with us now. Blake's not going to want to let me hear his voice, but Blake, Felicity and I have been working really well together. Oh, good. He unmuted himself. That's better. My honors class, I couldn't even get them to say hi. I'm not sure if you had a question on this at all, Blake, but when you're working with the Knowre problems, really I do suggest sketching this on your own paper and then looking for that pattern, because legitimately the first probably 3 to 5 questions are going to be filling in the blanks. And then I think they might adjust it a little bit where it only asks you to identify the geometric means. So when you do that, remember every one of the geometric means, those segments that are kind of like reflexive, they're in the same position, they're in 2 triangles at the same time, they don't correspond. So when I look right now at SP, SP is the leg of this triangle here, but it's the hypotenuse of this triangle here. And Felicity, because you gave me the numbers you gave me, in this triangle, it happens to be the longest leg, but in this triangle, it's the longest of all sides. Don't correspond, but they're the same length because they came out of here. When I look at the other leg, it would have the same explanation. In the original big triangle, it's this leg here, the shortest leg. But in this triangle, it's the hypotenuse, the longest side of this triangle. So they're the same length, they're the same segment, they don't correspond. And then this segment out of this right angle, the altitude, it's CP. You can see down here, it's repeated. Same segment, same position, almost even looks like all the other reflexive stuff we've talked about before, except in this triangle, it's the shortest leg because it's opposite the smallest angle. And in this triangle, it's the longest leg, it's opposite the largest angle. So again, just kind of throwing in numbers like we did before, Felicity, it gives us the opportunity to kind of really see that it's the same length, they just aren't the same segment, they don't correspond. They don't match up. So that's why we call those the geometric means. So I'm going to add that here at the bottom because I've already defined it before. I won't rewrite that. But the geometric mean segments SP, CP, and NP. And again, they all have to come out of that right angle for it to have that meaning. So that kind of covers probably over half, if not all, of the 9-1. Okay. So does that help any?
Yeah.
All right. So then these were the other 2 questions that I got asked. And one of the things that we talked about last week was a very lengthy, as I look for the other notes from last week, a very lengthy step-by-step starting on Monday, where we identified the parts of our right triangle. We were reminded what an altitude was. And then we talked about just what you saw me describe, why they were similar because of the right angles and the reflexive angles. And I talked about finding the pattern here. And then we talked about, if we went back to chapter, the similarity chapter, that any 2 similar triangles, we can write these proportionality statements, matching first 2, second 2, second 2 to get those segments. And I did it with all 3 combinations. What I then begged everybody to do was find the duplicate segments where they repeated, and that's what we just talked about, those geometric mean segments that don't correspond but do get repeated because they're overlapped. So I pulled those proportions out, and that's actually what those geometric means were. So when we would go to solve something like this and we cross multiply, you end up getting something squared equals 2 things multiplied together. Something squared equals 2 things multiplied together. Something squared equals 2 things multiplied together. And that's what that phrase is here at the bottom. So then on Wednesday, when we picked this up, we talked about, if I don't want to write out those proportions every time, Here's that cross multiplication already after it's happened. The two things that were the same, something squared equals two things multiplied together. Something squared equals those other two things multiplied together. And these all come out of this right angle. Notice how A, H, and B all come out of that right angle. So this allows us to cut to the chase. Mr. Colahan, when he teaches this, he teaches his students to memorize leg squared equals adjacent part times the whole hypotenuse. Leg squared equals adjacent part times the whole hypotenuse. Altitude squared equals part times part. Now, one of the things that I did stress with just the honors class this morning, because they had some similar questions, notice on this side of my equal sign, if I write out all the formulas, it's every segment out of that original first right angle. Everything over here is on that original hypotenuse. Notice how X, Y, and Z are all across this original hypotenuse. So that kind of helps know, did I do the right formula or not? What was squared has to come off of that right angle. What it is multiplied together on this side has to come from this hypotenuse. And then just on Wednesday, I said, let's change the letters, because what if the letters aren't the same? What if I turn the triangle? Which ones come off of the right angle? Here's that original right angle again. Here's R, S, and T, giving us again that hint as to which ones are allowed to get squared, the geometric means. And then the only other two letters get used are on that hypotenuse, which is M, P, and N. So all three of these letters are allowed to get used on this side. Leg squared, adjacent times hypotenuse. Leg squared, adjacent times hypotenuse. Altitude squared, part times part. And that's what I kind of wrote down over here. So I did all that because that's what's used here. Now, some will say that they can already see what formula to use because they've got the formulas in front. Others have no idea what that even means. So I'm going to do the first one as a strategy that eventually will help either remember the formulas or leave all the guesswork out. You won't have to worry about guessing what formula to use because you're going to actually write out all the formulas. So notice how there are no other variables around here like you just saw on that other sheet. So I'm going to go ahead and name this A, B, X, and C. It doesn't matter what letters I use. I could have used LMNOP, RST you just saw we used. I could have used WXYZ, V. Doesn't matter. Just every segment now has some variable or number. So with this strategy, I'm going to write out all of it, and then I'm going to write every one of those three formulas out. First thing I want to do is make sure I know where that original big right angle is. And these three are the ones that are allowed to get squared. These are those geometric means, those repeated segments you saw in my proportion. And I'm allowed to do A squared. I'm allowed to do B squared. And I'm allowed to do 15 squared. Felicity, because you're not muted, but Blake, I'm going to ask you to unmute here in a minute. Felicity, can you tell me what you think A squared is going to be equal to? What times what?
Would it be X and C?
You are absolutely correct. So we have leg squared equals adjacent part times the whole hypotenuse. So Blake, using that same pattern, can you tell me what B squared is going to equal?
B squared would be,
so B squared would be adjacent part times the hypotenuse. So what do you think?
so 40, 15.
40 and,
Oh, C.
yep, the whole hypotenuse. So A squared is XC, B squared is 40 and C. So then what's 15 squared going to be?
It's X and 40.
Perfect. So one of the reasons I said this is a good strategy is it has you practicing the formulas every time, so that maybe now in the next one, you don't have to do that every time. And because DC is really the only one we're looking for, I only care about the formulas that have X in it.
Mhm.
Well, can't do anything here because there's no numbers, don't care. And this one has everything we need. And we get 15 squared equals 40x. Now, I will tell you that in your calculator, we are going to want to divide by 40. And of course, we're going to get a decimal, and everybody's going to go nuts when they plug it in on Knowre and it doesn't give us the answer as a decimal. So just remember, 225 divided by 40 is a pretty nice decimal. So we would think, yay, let's plug it in. You know that this is now when we're truly being held accountable for exact value. So change that guy to a fraction. And it's actually 5 5/8. So when we do this division, make sure if you do get the decimal, change it, because they will not accept, and none of the standardized tests accept decimals unless it's one of those multiple choice situations. So 5 5/8 is how you have to plug it in our computer. All right. So now I can either use this work that I have over here to kind of help me know what I need here. I'm going to say I'm not going to do that strategy. What I'm going to recognize is that they've labeled the leg of this original right triangle, which means in any other of these, we have leg squared was part times hypotenuse. Leg squared was adjacent part times hypotenuse. So over here, I have a leg that I can square. I have its adjacent part. What's the only thing I need? Think over here, we have a squared was x times c. B squared was 40 times c. And those were the two legs. So leg squared is the adjacent part times what? And if you're looking in your notes, that's good. But look up here. We have a squared was x times c. So look at x and look at c. B squared was 40 times c. Notice that this is like a and b. 9 is like the 40 and the x. So what part do I need?
The long C part that you have in the, yeah, that.
Yep, we need our hypotenuse. That original hypotenuse across from that right angle happens to be what we're looking for. So now, just like we did here, we're going to do leg squared equals adjacent part. So this part down here that's adjacent to it on our hypotenuse, times the entire hypotenuse, which is C, or MP, doesn't matter. We end up with 121 equals 9C. And again, we don't have to take a square root. We need to divide away that 9. And we get that guy. Change that to our second F to D thing right there. We have 13 4/9. And again, they're going to want that as our answer, not a decimal. I will tell you it gets easier as you practice it, but this is always a foolproof strategy. Does that help a little bit probably with that?
Yeah.
I want to say like the last probably 5 questions look just like this.
Okay.
I am going to upload the same question. Let me rephrase that. Questions that I did with the honors class this morning, because they're the same problems. It's just every time you click on number 3, it generates the same question, but different picture. different numbers so that it's not just let's do the same problem again. The other thing to keep in mind, and I am certain that like 2% of the students have done this, they have a video you can watch. You can do a step-by-step with them. So there's opportunities to get help. And I think they give you like 2 or 3 tries before they say, nope, but then you can go back and try it again if you want. And I know that's a lot of trying, but sometimes after you've made a couple mistakes, you realize what you're doing, and that then alleviates that mistake for the rest of the question. So 9-2, I have been told by a number of people that the first like 12 questions, 13 questions are a piece of cake. It's just the Pythagorean theorem. And it's those, is it acute, is it obtuse, and using the formulas. And then the last couple have you actually doing more than just one step. So I have this guy that looks ridiculously involved. And because you guys decided to show up and make me feel like I'm doing something and not just talking to my screen, I'm going to give you the work through on this and let you ask me any questions you have. And that way it makes it a little easier for you to complete number 15.
Okay.
When you look at this, and I'm looking to see if I don't even have a box, but the idea is, ooh, I have a DVD. It's not exactly, it's a prism, but I want you to think about if we were looking at this, the front of this DVD is kind of the front of this guy, the BCRS. And this, granted, small guy, is this. If we want to find this length from B to P, I actually need to know the underside of this, what this length is. So the diagonal across the bottom of that. So I need this piece. And that actually happens to be a right triangle down there. So the first thing I'm going to do is I'm going to solve for that, that hypotenuse. And so this is 12 squared plus 4 squared equals hypotenuse squared. So leg squared plus leg squared equals hypotenuse squared. Again, our Pythagorean theorem. 144 plus 16, and we end up with 160. I am going to check that. 160 equals SP squared. It is going to ask you to do this in radical form. Right now, though, for the purpose of this question, here's the trick. Take the square root, and because this isn't the final answer, and I'll put that in my notes later, I won't waste your time writing it out right now. It isn't the final answer. So I'm not going to simplify this right now, because when I go to plug it in for the next question, I want this to be a little easier to work with. If this was the final answer, I've got to keep going. So I'm going to label this right here as the square root of 160. Again, not the final answer. What I am going to do, though, is now I'm going to pull that triangle out over here. And we have now BS, which is 6 inches. We have SP, which is radical 160. And we have BP, which is actually what we're trying to find. And again, because this is a prism and it's a rectangular prism, we get those right angles that have to show up. So this rectangular and it's a much lengthier description, this makes sure that we know that we have right angles everywhere. So that's why it's even so important to read that, so you don't question how come all these right angles keep showing up. It's a rectangle. They're going to have to. And we do our Pythagorean theorem again. So we have 6 squared plus this radical 160 squared. And that's why I said leaving it as is going to actually make this a lot easier. Because what's going to happen when you square a square root? What happens to those two symbols?
They cancel out.
They're going to cancel out. So that's why it's kind of nice not going through all that trouble, because now you're just looking at 36 plus 160 equals x squared. And now that we're done, we end up with 196 equals x squared. Well, I already know what the square root of 196 is. At the beginning of the year, I offered extra credit, but I will go to my calculator to double check. It should be 14, and it is. So we end up with a very nice 14. Had we not used that radical, had we rounded it as a decimal, you never would have gotten that answer. That's why exact value truly is important, especially when you go further and we go into science and we go into engineering and we go into all of the real life stuff. If we didn't have the math behind it, your real life situations for measurements would never be what they should be. So that's something we want to look at there. So when you do input this into Knowre, we find out that BP is a very nice 14. Now I did this question on the computer, and it was different numbers. And I will tell you, just so that you can see my scrap work, I just wanted to make sure I wasn't missing something when I talked to you guys. Same steps. Instead of that 160, it ended up in my example with R's and Z's and N's was 106. I took this over here and I ended up with 206. When you take the square root of 206, you find out that it doesn't simplify at all. Like it's not going to be something nice like you see kind of up here, 6 radical 2. It stays the square root of 206. And I plugged that in, and this was my answer. So remember, when you go into Knowre, as you click in the answer box, a bunch of stuff pops up, and those are all those access buttons where it allows you to do a fraction. It allows you to do the radical. You need to click on that radical button so you can put this guy under it. So this work was on a different question than that, but it's 2 Pythagorean theorem questions. So the last one, and I did the work already for that, is I think Albert and Henry. And this is again a question right on your Knowre. So I'm giving you guys another answer, and hopefully that'll help when you go to do that. It says one guy wants to do a fence around something that is isosceles. So the tick marks are already even in the problem. So if this guy's 6, this guy's got to be 6 yards because it's isosceles. The other guy has a yard that is 7 by 15, and they want to put a fence around the perimeter. So the idea is perimeter, which means we need this length and we need this length. It does say that for every yard, it's going to be $65 at the store. They're going to ask you who spent more and how much more. And this how much more is important because it's not going to be what's their total spending. It's subtract. So over here, we have, I already was going to get to it, 6 squared plus 6 squared equals VM squared, which is, that's where my 3 was coming from, 36 plus 36 equals VM squared. And we end up with 72 equals VM squared. So the square root of 72, if we did, this is actually, when we simplify, the square root of 36 times the square root of 2. Kind of makes sense considering we had 2 36s up here. So 36 times 2 is 72. Oh my goodness, what is my problem? And we end up with 6 radical 2. Now I am going to say, because of how I just did the last question, because this isn't the final answer, you could have stopped right here at radical 72 and kind of saved yourself some time. I did this just to kind of remind us how to simplify, but because it's not the final answer, I'd have been okay with you just stopping here. So we have this 6 radical 2 as that hypotenuse. Because I want perimeter, my perimeter is actually 6 plus 6 plus 6 radical 2, or what would be 12 plus 6 radical 2. Now, I'm going to go over here. I'm going to do this problem again, except this time we're going to do 7 squared plus 5 squared equals jk squared. So 49 plus 25, and we end up this time with 74 equals jk squared. And when we take the square root, there is no way to break that down. It is just the square root of 74. So when we do the perimeter of that guy, it is 7 plus 5 plus the square root of 74, which does mean you end up with 12 plus the square root of 74. Now, if you would have left this one as the square root of 72, you already can answer one of the questions without even having to go any further. Obviously, 74 is bigger than 72. So even if you take the square root of it, the values are still going to be bigger over here than it is over here. So one of the questions was Henry or Albert in my problem, who was going to pay more? This guy, because his fence is more. So if his fence is more, it's going to cost more with the way it's been configured here. So, but then the next part of the question says how much more, which then means I've got to take out my calculator and I've got to figure out what it is times 65, and I don't want to round. So here is where I'm going to suggest why we keep it as 12 plus the square root of 72. It's easier in the calculator. So the square root of 72 is that, and I'm going to put plus 12. Now I'm not going to take it off my calculator, but I do know that that is going to be approximately 20.485. But because I'm not taking it off my calculator, I am going to now multiply by $65. And by pushing times 65, this is the value that I want to write down. And because it's money, I want to make sure that it's to the nearest penny. So when I look at 4, the number after it, 3, tells me if I round up or stay the same. Well, because it's 3, I'm going to stay the same. So this is $1,331.54. So $1,331.54. Had I rounded before, it wouldn't have been this number. So that's why exact value is so important. So now we're going to come over here and we're going to take the square root of 74, leaving it on my calculator, add 12, and it's 20.602. Again, I'm leaving everything here, but just jotting this down. I'm going to multiply by that 65, so I get every value involved. And now this one, rounding this to the nearest penny, we can see it's 15 cents here. So this guy right here tells me, do I round up or stay the same? Well, because it's a 1, we stay the same. Had this number right here been 5, 6, 7, 8, 9, that would have turned to 16 cents. 0, 1, 2, 3, 4 keeps me at 15 cents. So my answer here, $1,339.15. So it asks, how much more is the guy going to spend who ended up spending more? Well, I'm going to take my 1339.15 and I'm going to subtract my 1331.54. And I will tell you when I plugged that in, it was the correct answer. I plugged in a different answer at $7 and I think it was 68 cents because I had rounded and it was wrong. I did everything correctly, but because I didn't use exact value, it told me I was wrong. So keep that in mind, that you want to keep every decimal place on your calculator. All right. So those were the questions, and I wanted to make sure you guys had those at least from the end of the Pythagorean theorem 9-2, because those were the most difficult, I really do believe. And I wanted you to at least have a jump start and a kind of a little extra on the side. Can you think of any questions that you have for me that with the no reassignments, or maybe even something about grading or late work? Again, Blake, you were a little late. I'd already told Felicity if you're still going to hand something in, email me what you want to hand in. And if it was from third quarter, I can try to get that accounted for somehow in the fourth quarter. And that way it eventually all averages out when your semester grade goes in. And I know that somebody would argue, well, the percentages are so crazy, who cares? It does truly matter. So if there's any questions you have, ask.
Okay. I'm all good, thank you.
Awesome. Felicity, you got anything else?
I'm pretty good too. I just kind of want to know if these no reassignments or are today's homework. Are they today's?
Okay, so the Knowre ones I assigned, I think either Sunday night or Monday, and I said you really wanted to try to get them done by Sunday. So I try to do Sunday to Sunday as kind of benchmarks.
Okay.
The actual computer program won't shut them down, I think, until May 11th. What I don't suggest, though, is putting too much off, because I'm going to add an assignment next week. And I don't know if it's one or two things, but you know as well as I do, putting them off and then having 5 things to do at the last minute feels very overwhelming. So that's why I try to give us, a benchmark to work towards so that it's in and we don't have to worry about it being overdue. Does that make sense?
Yeah.
Okay, because I do have a couple people still need to take, turn in their test. So now on top of trying to do their test, they're trying to finish 9-1 and 9-2 from Knowre. And then if they're still trying to finish those 3 things and I add a 4th thing on Sunday, now it really feels overwhelming, where before it was, oh, I'm done and I have nothing to do. So that's all. You still have quite a bit of time, honestly. And even after the computer shuts down, you can always work on your Knowre. So let's say you didn't do something in 8-3 or 8-4 or 8-5. You can do that and take screenshots of that, of your achievement at the end, and it lets me see when you email me that screenshot of 8-3 that you've completed it, and then I can go in and double check for you. So then you can still get credit for that, even though the computer has shut down. Where it's going to go into the actual assignment, I still can record it. So it's kind of the workaround for Knowre.
Okay.
All right. Thanks, guys. I appreciate it. I hope you guys have a great weekend. It's sunny now, so maybe catch some fresh air.
Bye, Kat.
Thanks, you too.
See you guys.
Bye.
Bye.